All right, so welcome to the day 8 video on solving systems of exponential equations graphically. We're actually not going to do inequalities in this lesson, so you can ignore that. So in our last lesson, we talked about how we would solve problems like this where we'd get common bases and we'd set the exponents equal to solve and so on and so forth. But it doesn't quite work with 2 to the x plus 3 equals 7 because you can't rewrite 7 with a base of 2. So what we do instead is solve this graphically. I can put the left side in the calculator in for y1, the left side of the equation in the calculator for y2, and solve it from there. All right, let's see. Clear. Okay, so I got 2 to the x plus 3 and 7. Now if I do a zoom 6, that should give me a decent window here. So here is my exponential growth function that's been shifted to the left 3 units, and there's y equals 7. So if I wanted to take the time, I would graph this using my table. Hopefully you guys are okay with me just explaining it here because I think you guys should all know how to graph. The idea is you're just finding that intersection point. So I'm going to hit second trace, intersect, which is option 5. Now, it's going to ask you what the first curve and second curve are. Just hit enter twice. You guys are never going to be graphing more than 2 equations at the same time, so just hit enter twice. Now, guess only really matters if there's more than one intersection. There's only one here, so just hit guess again. And there you go. So x equals negative 1.926 ... And then it's 7. Now, the equation is only looking for what x is, so this is your answer, because it's saying find the value of x. Now let's see, does this make sense? Does this check? So if I pull back up my calculator and I go to my home screen, if I hit second answer, which is this little negative, that actually pulls up my previous x value that I just got from my graph. Now, I'm going to store that as x. Okay, so that's my answer. Now, check this out. If I do 2 to the x plus 3, I should get 7. And I do. So it does check. And that's it. That's solving for x. So, if I want to solve something like, I don't know, let's do 2. Again, you're just doing, actually no, let's do 1. y1 equals the left side, y2 equals the right side, and then we find the intersection. So here I go. So I'm just going to type this in as 0.5. So 1/2 to the x minus 1. And then I got 8 on the other side. Oops, I should say x minus 1. Okay, 1 intersection. I hit second trace, option 5, 1, 2, enters. Now again, just hit enter one more time because there's only 1 intersection, and there you go, x equals negative 2. Now like I said, if I wanted to take my time here, like if this was a test or something, and I would show my work by actually doing the graph, I'm just saving time in this video, just explaining where these answers are coming from. Okay, now let's look at number 2. There's my exponential growth function, and here's the line y equals x plus 2. If they don't intersect, there's no solution. So make sure you don't say 0, because 0 implies x equals 0. This is just no solution if they don't intersect. All right, I'm going to skip ahead to a word problem. So the following equations represent the annual attendance at 2 different events, A of x and B of x. Let x represent the years since 2004. So it's always important, guys, to note what your x value represents. Now, before I get into this, keep in mind A of x is an exponential growth function, and it looks like it's growing by 25% per year. And my initial attendance for whatever this event is 4,000 people. My other function, b of x, is decaying. Oops. And I know that because the b value is less than 1, and we're decaying by 13%. Because it's that difference from 1. I do 1 minus 0.87, which would be 0.13, multiply by 100, decay by 13%. And that's, again, per year. It's always good to actually understand what you're looking at. So using your calculator, determine when the two events will have the same attendance, aka when are these two functions equal to each other? When is a of x equal to b of x? So I'm going to go to my calculator and type in both. Now, keep in mind that if you do a standard window, you're not going to see much because your initial value is at like 12,000 for your second function. So before I even do a graph, let's go to my window and set my y max to like 13,000, just so you can definitively see that initial value on b of x. And then I'll hit graph. So here's a of x, that's your exponential growth. And then there's b of x, that's your decay function. Right there is where you're going to end up seeing that intersection point. Okay, so like I said, whenever you're doing stuff in the calculator, you're going to want to sketch a graph. So for this one, I actually will. Let's sketch a picture. Okay, this is my exponential growth function. This is my exponential decay function. They're intersecting right there. That's when their attendance will be the same. So second trace, option 5. First curve, second curve, guess. There's only one intersection, so just hit enter 3 times. And there you have it. It's at like 3.03. Dot, dot, dot. I'm just not going to round it. And then my other guy is 7867. Dot, give me a couple decimals, 509. Dot, dot, dot. Okay. So using my calculator to determine when the two events will have the same attendance, and we'll round to the nearest year. Well, if this is years since 2004, but it's going to take about 3 years for them to have the same attendance, that means in the year 2007, they would have the same attendance. How many people to the nearest 100 would attend the party that year? Well, ones, tens, hundreds, we're rounding to that place value, so you should be thinking 7,900 people would be at each party. It says party. I love how it like starts as an event and then all of a sudden it's a party. All right. Now, before I go to do the next page and talk about something, let's actually take a peek at 5. I skipped this one. All right, so likewise, I'm doing left side is 2 to the x plus 6. Right side is 2x plus 15. I'll do a zoom 6 just to reset my window. And there you have it, guys. There's actually 2 intersection points here. So what you need to do is still go to second trace and find the intersection. Okay. You can pay attention here to find where your cursor is. See how he's on the first curve? He's on the exponential, so hit enter. Then he jumps to the line. Now here's where guess is important. Depending on who the little blinky guy is closer to, that's the intersection it's going to find. So like he's closer right now to this intersection point, so if I hit enter, that's where he's going to go. So my first intersection is, to solve for x, is to the nearest 100th. negative 2.75. Second trace, option 5. Enter, enter. Now guess is where it's important. Move it to the other intersection. Notice how now he found him, and that's negative 7.296, so that's negative 7.30. Okay, and that's how you'd solve those. So this was just a nice one to hit up only because there were 2 intersections and you had to move the little guess option around. You can ignore number 8. That was a mistake. We meant to change that problem. I actually don't think I'm going to do these. I think that was good. So that's the idea, guys. You plug them in, you find your intersection, and then interpret what that coordinate of intersection means. If you need to see the calculator steps, now you can see them in this video.